27. What should I do first? Distribute. So we distribute the exponent to everything on the inside. So we have 3 to the power of negative 3. What do I do when I have a power raised to a power? Multiply. So this would be x to the power of negative 12. Y to the power of what? 9, because it's negative 3 times negative 3, and z to the power of negative 3. Now, if it has a negative exponent, what do I do with it? Put it on the bottom. So everything that has a negative exponent is going to go down to the denominator. If it has a positive exponent, it stays up top. So y to the 9th power stays up top. Everything else gets moved to the bottom. So it's 3 to the 3rd power, x to the positive 12th power. Now that we move it, we flip the sign of the exponent, and z to the 3rd power. What is 3 to the 3rd power? 27. So y to the 9th power over 27, x to the 12th power, z to the 3rd power. Any questions here? All right, looking at 28. What should I do first? We could distribute. What else could we do first? Let's simplify the inside. That way we don't have to distribute to so many things. So I'm going to start by simplifying the numbers. What is negative, we'll call it negative 1 on top, divided by negative 7? Just 1 over 7. A negative divided by a negative turns into positive. So let's just get rid of our negative signs there. Now with the x's, I have x to the 4th power and x to the 11th power. Can I still combine them even though they're not right on top of each other? Yeah, that confused a lot of people on the quiz. You can still combine them together. They're still the same variable even though it's in a different order. So when I'm dividing, I subtract. So it'd be x to the power of 4 minus 11. What's 4 minus 11? Negative 7. So x to the power of negative 7. Let's do the y's now. So that would be 3 minus negative 5. When we subtract a negative, it turns into plus. So 3 plus 5 is 8. So y to the 8th power. And then with the z's, it would be 9 minus 3. So that would be z to the 6th power. And then everything still has the exponent of negative 2. Nicole, what can we do next? Now we can distribute. You could have distributed in the first step. You'd just be distributing to 8 different things. So it's just easier to simplify and then distribute. You can. So if you wanted to, when you subtracted, if you know that it's negative, you can bring it down. But my exponent's negative, so it's going to change the sign of it again. So you'd have to move it again. But that would be doable. You'd have to move it twice. So distributing our exponent. What do I do when I have a power raised to a power? Multiply. So this turns into x to the power of 14. And then y to the power of negative 16. And z to the power of negative 12. And 7 to the power of negative 2. Now, a lot of people, when they distributed that exponent, they wanted to evaluate the 7 to the power of 2 right away, and then they forgot to move it. So they just thought this was 7 squared and left it as 49 on the bottom. But we can't evaluate it if it has a negative exponent. What do we have to do first? What do? Move it to the top, make it positive. So any negative exponent, we're going to move it to turn them positive. So x to the 14th power stays on top. We also have 7 to the 2nd power on top now. Y to the 16th power on the bottom, and z to the 12th power on the bottom. Now we can evaluate 7 squared, which is what? 49. So 49x to the 14th power over 16, y to the 16th power, z to the 12th power. That would be our final answer. All right, so going back to number 1, let's do some factoring. What should I do first to factor number 1? Take out the GCF. Always, when factoring, think to yourself, do I have a greatest common factor? It'll help a lot when you take out the GCF, and then if you need to factor it normally, your numbers are a lot smaller, so it's easier to work with. So always ask yourself first, do I have a GCF? What's the GCF here? 7 what? 7v, because they all have a v in it too, so 7v. So I'm going to take out the 7v. What am I left with? 63 divided by 7 is?
Oh, wait, sorry, plus 9.
Plus 9. Perfect. Now let's see if we can factor this more. When factoring, if we have a leading coefficient that's not 1, what do? Multiply the first times the last. So 5 times 9 is 45. Do we have two factors of 45 that add to 4?
9 is negative.
What's 9 times negative 5?
Oh, times?
Well, 9 times negative 5 would be negative 45, which isn't positive 45 that we're looking for. It's got to multiply to 45, but add to 4.
Oh, my bad.
So 9 and negative 5 would add to 4, but that multiplies to negative 45, and we're looking for a positive 45. So do we have any factors here? No. So this is as factored as it can go. Just taking out the GCF, that's all we can do. All right, let's look at number 3. What should we do first? We can take out the greatest common factor. What's our GCF? 9. 9, and how many n's? 9n cubed. Because this one has at least 3 n's. So when we take out 9n cubed, we write that on the outside. What are we left with?
1 plus 4n plus 9 squared.
Awesome. 1 plus 4n plus 9n squared. Can we factor this? Does it factor anymore? No. So this would be our final answer. All right, for number 5, how would we factor?
Multiply the first one. Actually, oh no.
This one's just basic factoring. We don't have a number out front, so we don't have to multiply the first times the last. So we just ask ourselves, what are two factors of negative 15 that add to 2? 5 and negative 3. Perfect. So we'd write our answer as v plus 5 times v minus 3. For 7, we do the same thing. What are two factors of 6 that add to negative 5? Negative what? Negative 3 and negative 2. That multiplies to positive 6 and adds to negative 5. If you said negative 6 and 1, what's negative 6 times 1? Negative 6. So just be super careful with the signs. So we have p minus 3 and p minus 2. For number 9, what should we do to factor? Let's take out the GCF first. You can multiply the first times the last, but let's take out the GCF, make the numbers a little bit smaller and easier for us. What's our GCF? 3. So we're going to divide everything by 3. That goes to the outside. When we take out a 3, what are we left with? plus 7m plus 2. Now what can we do? Multiply the first times the last. So 5 times 2 would be 10. What are two factors of 10 that add to 7? 5 and 2. So we have m plus 5 and m plus 2. We can't forget our GCF that we took out in the beginning, so we just put that 3 out front. Am I done?
No.
What do I have to do? Awesome. If you start by multiplying that first number, you have to remember to go back in and divide it. So 5 divided by 5 would be 1. What if it doesn't divide? What do I do? Move it in front of the m. So 5m plus 2. So we have 3 times m plus 1 times 5m plus 2. Let's look at 11. What should I do first? Multiply the first times the last. We don't have a GCF, so we multiply the first times the last since our leading coefficient is not 1. So we get 24. What are two factors of 24 that add to 11? 8 and 3. So we have n plus 8 and n plus 3. What else do we have to do? Divide by 2. So since our leading coefficient, we started with multiplying it, we have to remember to go back in and divide. So we get n plus 4. And it doesn't divide in the second one, so we move the 2 in front. So 2n plus 3. What should we do first for 13? Multiply the first times the last. We don't have a GCF, so we multiply the first times the last first. We get negative 60. What are two factors of negative 60 that add to 4? 10 and negative 6. Good job. So p plus 10 and p minus 6. What do I have to do next? Divide by 4. What should I do next? Simplify. Can we simplify 10 divided by 4? Yeah. What goes into both 10 and 4? 2. So this simplifies to 5 over 2. Now what do I do with the 2? Put it in front of the p. So 2p plus 5. And do the same thing with the second fraction. Can I simplify 6 over 4? What does it simplify to? 3 over 2. So I take the 2, move it in front of the p, so it'd be 2p minus 3. If you didn't simplify in this step and you just moved the 4 in front and the 4 in front, when you FOIL it back out, you would have gotten 16p squared, which is not 4p squared. So always check your work, especially just even multiplying the first 2, check and see if you did it right. 2p times 2p would be 4p squared. How would I factor 17? It's the difference of squares. Difference of squares. How does the difference of squares factor? It's like conjugate. So you get a plus b times a minus b. So difference of squares ends up being 2 sets of parentheses. Well, let's find out what our a and our b are. So we would take the square root of both of these. What two numbers gives us 9n squared? 3n and 3n. So, and what two numbers gives us 25? 5 and 5. So when we write it out, we get 3n plus 5 and 3n minus 5. Doesn't matter the order. I always put plus first just because that's the way my brain works. But if you guys are comfortable putting minus first, that's fine. The order for all of these, the order doesn't matter. Like for this one, you could have had them flipped. Still right. So 19. Again, we have 2. Most of the time, if you have 2 terms, it's going to be the difference of squares or a GCF because you can't factor it like a normal trinomial. So if it's 2 terms, check and make sure that they're both perfect squares. Then you just use the difference of squares. So what would go into the parentheses here? Awesome. X minus 3 and x plus 3. All right, let's look at 21. I have 4 terms. Anytime we have 4 terms, how do we factor? Grouping. Group the first 2, group the second 2. So anytime you see you have 4 terms, first thing you need to think of is grouping. So group the first 2, group the second 2. Sometimes it's not always going to be the first 2 that go together, but we'll see that in the next question. So for 21, what's our GCF in the first group? 6, 6a squared. So we take out a 6a squared. What are we left with? 7a minus 4. In the second group, what would we take out? -1. Why are we taking out a -1 here? So the insides can be exactly the same. We see that if we need a 7a minus 4, here we have a -7a plus 4. We need the signs to change for both of them. So we're going to take out a -1 and flip the signs. So 7a minus 4. Now that our insides are exactly the same, those go together as one parentheses, so 7a minus 4. And then the 2 outsides go together, 6a squared minus 1. All right, let's take a look at 25. So 4 terms, we know that we have to factor by grouping. Can I just group the first 2 and group the second 2 here? For 25? No, if we tried it, our variables and the numbers would be off. It wouldn't work. So what do you think we have to do first? Rearrange it. So I'm going to put the x's together and then put the b's together. So I have 24xy minus 15x. And then my second group, I'm going to group the other 2, but notice how in my first group, what's my GCF going to be? 3. 3x. So when we take out a 3x, what are we left with? 8y minus 5. So I know that my second parenthesis has to go whatever number y and then the other number. So the first one, I want to have a y in it, so I'm going to put the next term as -64 by. Just because I know I want that y in that first spot to make my parentheses exactly the same. And then plus 40. What's my GCF here? Plus 40b. 8, if we take out an 8, -8b. Perfect. If we took out a +8, the signs wouldn't match up. So it has to be -8b. So then I'm left with 8y minus 5. Are my inside parentheses exactly the same? So we're going to put those together. So 8y minus 5. And then the 2 outside parts go together. 3x minus 8b. Okay, I'm going to do one other question. I noticed it wasn't on the review, just in case we see it on the test. So let's say we have 9x squared All right, 9x squared plus 12xy plus 4y squared. What can we do?
Both ends are perfect squares.
Both ends are perfect squares. What times what gives us 9x squared? 3x and 3x. What times what gives us 4y squared? 2y and 2y. You can check the middle just to be sure that we can do this, because it's always going to be 2 times the first times the last. So 2 times 3x times 2y, that would be 12xy. So we can do our little shortcut here. So this is what we call a perfect square trinomial, which ends up in one set of parentheses squared. What would go into the parentheses? 3x plus 2y. How did you know it was going to be a plus? The sign in the middle tells you what the sign in the middle is going to be.
Is there any rule that like you can only do this?
All right, next page. So here we have our binomial cubed. We can use our shortcut. Our shortcut is a cubed plus 3a squared b. Or I guess it uses u and v, but it's the same thing. Plus 3ab squared plus b cubed. We just have to be careful when it's a minus in the middle, also when our first term has that negative there. So our first term is going to be negative x. Our second term is 7, but because we have a minus, our signs alternate. So it's positive, negative, because of that minus in the middle. So now let's plug in what we have. So I have negative x cubed minus 3 times negative x squared times 7 plus 3 times negative x 7 squared minus 7 cubed. Negative x to the third power would be what? Is it positive or negative? What do you think? If you have negative x times negative x times negative x, it would be negative x to the third power. Then the next one, when we have negative x squared, that would turn into positive x squared. But we still have that minus, that negative 3. So negative 3 times 7 is negative 21x squared. Next, we have 7 squared, which is 49, and 49 times 3. Let's write it out. 147. It would be minus 147x. And then minus 7 to the third power would be 49 times 7. 7 times 9 is 63. 4 times 7 is 28, plus 6 would be 34, 343. So this would be our final answer. Any questions here? All right, let's look at 30. I'm going to do 30 the long way, so foiling it out. So if I have 2x minus 3 times 2x minus 3 times 2x minus 3. A lot of people tried to do it the long way, but like, I don't know, their math didn't math, I guess. So when you multiply the long way, you have to FOIL 2 of them first. You can't FOIL all 3 of them together at once. Just pick 2, FOIL it up. So starting with our first, we get 4x squared. The outside would be minus 6x. The inside would be minus 6x, and then plus 9. Combine like terms, we get 4x squared minus 12x plus 9. Now we have to multiply this to the third one, so 2x minus 3. So just make sure everything in the first set of parentheses gets multiplied to everything in the second, bless you. So 4x squared times 2x would be 8x to the third power. 4x squared times negative 3 would be negative 12x squared. Negative 12x times 2x would be negative 24x squared. Negative 12x times negative 3 would be positive 36x. 9 times 2x would be 18x. And 9 times negative 3 is negative 27. What's the last step? Combine like terms. We start with 8x cubed When our squareds go together, that would be negative 36x squared. The x's go together, which would be 54 plus 54x minus 27. So you could do it the shortcut like we did in 29, or you could do it the long way. Just be careful with the math. Both ways there's a decent amount of multiplying, so just be careful.